welcome to my talk on attributes in PHP 8. I'm very happy to see so many of you here. The topic is about using metadata in a programming language, such as PHP in this case, and from a historical perspective, metadata as a first-class citizen and not as sort of an afterthought being built by through Docblocks or something like this. Let me try and get the echo away. Yeah, that's better. Okay. So, what qualifies me to talk about this topic? I am Benjamin, and I'm an open source contributor. I am one of the core team members of the Doctrine team for a very long time already, and I'm also a PHP core contributor. Most notably, I've contributed the attributes feature and parts of it to the language for PHP 8. I am the founder of a company called Tideways. We are doing PHP profiling and application performance management. And I'm also a member of the PHP Foundation Administrative Board. And if that's something you haven't heard about, the PHP Foundation is a way for companies and individuals to sponsor the development of the PHP language, where we gather funds from different sources and are employing people to work on PHP as a language. At the moment, 6 people are employed by the foundation to work on the language part-time. It's the first time that PHP has had so many contributors regularly working on the language and being paid for it. And we are hoping to increase this to 8 people next year. That's quite exciting for the language to go forward. Okay, so attributes in PHP 8. What are attributes? Who has heard or seen or read something about attributes in PHP before? That's quite a bit, but not all people. Then who has used attributes, so actually using them in projects actively? So that's maybe a force or something. Yeah. Yeah, so I will go through explaining what attributes are. I will go into detail what is possible. So I'll show some advanced use cases. I will show how attributes came about. What are they useful for? And show a bunch of different examples from attributes that are in the core language of PHP and also from attributes that are in Userland libraries and some things you can do yourself with attributes. So it's a sort of a rough history and sort of like overview about everything related to attributes in PHP. So we start with a hello world example. Attributes are metadata that are machine readable for the language itself. So when we talk about things in a language, we give them a name, and like coming from the, let's say, design patterns allow us to give functions and classes a meaning about what their role is in an application. Let's say model view controller is a pattern. You have different classes that you can give a role. It's a model, it's a controller, it's a view. Event listener or subscriber observer pattern. You have classes that have the role of an observer, of an event listener, or something like this. So what attributes allow is to make this role available to the application itself in a machine-readable way. Let's say to tag something to play a specific role. In this example, we have a function hello world, and it echoes hello world. And that's sort of a quintessential example, I guess, of programming. And connected to attributes is like how, let's say, when is this function going to be called? And we want this function to play a role in the sort of web context where this function is available given a specific pass in the application, I want this function to be called. So this is sort of a role that I want this function to play. Whenever the application is executed with /hello/world, then this function should be executed. And attributes are sort of a meta-programming way of making this knowledge available to the application. Obviously, like this alone is not enough. So we have this function, we have this attribute, but attributes, they don't sort of magically happen and do something. You have to program it in yourself. Like, what is the behavior of an attribute if it's on a function, for example? So with attributes, you would go and write this kind of code in your application, and then you need to hook it up. So you need to make the attribute mean something. For example, in our case, we have a router and we have 2 steps. In the first step, we are collecting all the route paths. That means we are looking in the application for all functions that have this route attribute, and we are collecting them and registering them and keeping note that they exist. And as a second step, we use the current URL and we dispatch the application. So we say, given this URL, execute the function that is registered under this hello world path, for example. And this comes about by 2 things. So the route attribute that we used at the beginning, this actually maps to a class. So when you're using PHP internal APIs to get access to attributes, this here means it's represented by a class named route, and it's calling this constructor of the class. So we have in our code this class route, and we have the constructor for it here. So this is sort of the declarative way of explaining to the system that there's an attribute in our code base with this name, and it has this constructor. And PHP Storm, for example, will see this. And as soon as you write the syntax for an attribute, it will help you and autocomplete that we have this and this attributes available that you can use here. And now sort of comes the part of connecting those 2 things. We have this function, we have this route attribute, and now sort of we implement how this behavior works in our system. We are iterating over all the user-defined functions in our system. We will see later how we can maybe improve. This is sort of a very simple but brutalistic way of going about it. We are using the reflection API. So attributes is a part of reflection. And every element in reflection has a new function called get attributes. So get all the attributes that are on this element. Reflection has reflection class, reflection function, reflection property, and so on. And we say, give me all the route attributes. So we filter by this class here that are on this function. And on a lot of functions, there will not be any route attributes because they don't act as a sort of recipient of routes and in the system. But for those that do, we iterate over all route attributes and we collect the route and store it in this collect route path function. And again, this is sort of meta programming. We are programming in the abstract. We're having a reference to an attribute, a reference to a function on the reflection level. And we are saying, give me a new instance of this reflection attribute. New instance means the route class that we defined before. So at that point, PHP will call the constructor and make this an instance of the route. And calling the constructor includes the path that we have given to it. So we are storing now the path of this attribute, and we are storing the function that belongs to it as a reflection instance. So it's very generic programming. We are programming in the abstract by having reflection functions, reflection attributes available. but we gave it sort of a meaning. We are knowing what kind of functions are this and what kind of attributes, and we are connecting this to have a meaning for our application. So with this information available in our router, we can dispatch the current URL of the request. We are looking in the map at this URL, do we have a function available? And if we have a function available, we invoke it. So reflection function has a method invoke on it, which just calls the function. So it's like call user func array, or the more modern, just having a variable where a function name is in it and executing it. It's just a different way of dynamically calling a function when we have this reflection function available. If the path is not available, response code 404. So that is sort of a hello world of using attributes. We defined the route attribute at the function level, and we made this available. And since all the code goes through this dispatcher in our application, we can now just add a new function, add a route attribute there, and it will immediately be seen by the web application and will be callable under its own URL. So what attributes allows us is to decouple sort of parts of the system in a way where we define a concept like a route, and we are making the behavior available. We are programming it very generically against the reflection API, and we can just add more and more of these concepts that we have defined like a route to the system. And on a generic way, it's implemented once and it just works for the next use case and the next use case. So this is something that is very helpful for frameworks, for example, because frameworks don't know how they are used. They are just providing the system with sort of generic functionality, and then the user of the framework is making this specific to their use case. So attributes are a very nice way of a framework for providing functionality in a generic way. The user then attaches the right attributes to the right classes, functions, and everything, and this makes the functionality available and working. Okay, so metaprogramming attributes. Is metaprogramming attributes allow to implement a feature on the meta level without knowledge who will use it. So you're implementing it generically and giving this feature to somebody else to use and make life, put it to life. Attributes are a way of doing configuration in code. So specifically the routing example is something many frameworks have different ways of defining routes, for example, using XML files, YAML files, INI files, or maybe even in PHP code. But usually routing is something that is defined elsewhere. So you define a controller in your system, and then you have a second place somewhere else where you sort of register that this is available under this URL. And what attributes makes possible is to make this configuration in the same place where the element is available. So you add a new controller, and on the method of the controller, you immediately define route, and you're combining the both concepts on the same place, making it easier for a reader to connect those two, understanding that a class or a method is has a route, is available this way. So you don't need to sort of know about another place where you might need to look, but it's just readily available directly in the code. That's very helpful. Obviously, it couples the system a little bit more. Specifically, if you're using a framework, you suddenly have a framework annotation in your own code. But sort of it's a trade-off. It makes it easier to read. The simplicity of it makes it nice to use. So what is the history of metadata in PHP? So before this feature came available, there's actually 20 years of evolution that happened to make this feature into PHP language. And I want to quickly go through it. So metadata in code is not something that is PHP specific. At this time, I believe almost every other major language also has something like this. And it is sort of a concept that is widely spread. In PHP, we started this with Docblocks. And the first time this was thought about was in 2000. And the first version of PHP doc, a way of documenting the types before types were available in PHP as a language feature, they were in Commons. And the first versions of this needed to parse the PHP files before, in 2003, the reflection API got a way of reading the documented comment on, let's say, a function, a property or something like this. So at that point, it became more easy to read the comment of a function and build tools around it. For example, 2004, 2005, this is probably the most known annotation by everyone is @test, which you can use in PHP unit to mark a function as a test function if you don't want to use the test prefix name. Everything changed in 2010 when a bunch of crazy people, me included, released something called the Doctrine Annotations Parser, when we sort of made these comments strictly parsable so that they could be used at runtime in a production application. Before, most of the annotations were only used in tooling, like PHP doc generation, PHP unit, sort of just in testing. It was not really used at runtime in production, which changed with the Doctrine Annotation Parser. So how does it look like? Docblocks, you probably all have seen them. You have a function without types. And because that is hard to reason about as a human, we added this sort of way of documenting which type in which function so that it's easier to read and understand, and maybe produce less buggy code by using the functions correctly instead of passing the wrong types. So as I said, reflection allows you to get access to the doc comment. And if you do that, do a var dump, then you have the string here. And then what Doctrine Annotations did is build a parser for this here and map it to classes. So if you have an @entity annotation, then that would map to a class called entity. And then this looks very similar how attributes look today in the language. You say you have this property, and this matches a public property on the annotation. And then you can use the Doctrine Annotations Parser to, again, parse a reflection instance. The reflection instance would use the doc comment, pass the doc comment for this structured language, and instantiate actually the real entity class that we've seen before, and sort of populate this property correctly and make it available to runtime. It had a caching mechanism built around it, so it was quite inexpensive to use at runtime as well. So once people saw how awesome it is to do this in production code, the requests for inclusion into the PHP language came into play. And it took 10 years until this was finally included, and 7 different requests for comments. A lot of discussion around it, many different approaches, and I believe sort of the growth of the community at some point allowed this, where most of the people that were able to vote on the language feature saw this as something valuable, especially since all the other major languages added it also as well. And then it was just a question of what is the syntax and how we make this feel like PHP. Sort of, it must sort of fit in the language in the best possible way, so that it feels like a PHP feature and not a rip-off of a different language, how different language works. So I think that if you follow this at any point, the most words have been written about the syntax. And they have actually, after this feature was accepted, which was using this syntax here, I think 2 or 3 follow-up requests for comments that also had a lot of discussion until we finally settled on this syntax and rejected all of these different ones. And the reasons for the syntax discussions are like many different reasons. And that we picked this one was actually, it was a blessing, and I will show later why. It has a property that none of the others have that is actually awesome. And I think a lot of people wanted just the @ and then a name, like it's in Java. But that's not possible because in PHP, @ is used for the error suppression operator. And you can construct code examples where you wouldn't know if the parser would need to interpret this line as an attribute on something, or if it's actually a function that is called with an error suppression operator. So it requires a lot of parsing and look ahead to find a token far in the future to find out if this is an attribute or if it's the function. And that makes the compilation of this expensive. And all the people that are working closely on the language parser rejected it outright. So we needed to find other ways. This, for example, had quite a lot of followers. Yeah, it was a struggle. So that was voted into the language in 2020, 3 years ago, released in December of 2020. And it works the following way. You have a hash and then followed by brackets, and you define the annotation name here. That is the most simplistic way where you define this one here resolves to this use class here. So it's sort of calling the constructor of a function of a class in a shortcut way, because you don't have the new statement here. You only have it's similar to how with the short closures, you don't have to specify a return statement. It's just a sort of a condensed way of writing new test. Obviously, if you have a constructor, you can pass arguments. And since PHP 8 has named arguments, you can use named arguments to sort of declare them in a way where you specify the name of the argument first and then the value. So you can maybe change around from the actual definition of the constructor. And you can put multiple attributes on a single element, like a function. And there's a short syntax to combine multiple attributes this way, where you comma separate them. So this is equivalent to this. And the constructors accept arbitrarily complex PHP expressions with a few exceptions. So you can do an array of things with all kinds of scalar types. You can even instantiate classes that are passed to the constructor of the attribute, or reference constants. The only thing you cannot do is call a function and use that return value. That is not possible. But it's already, allows quite a few of complex structures and metadata that you can define for an element. Coming back to the hash syntax, and Alexander, as the major contributor to Symfony, will agree with me. The benefit of this is that in PHP 7, every line starting with a hash is actually a command and it's not executed. So the benefit of this syntax is that you can write code with attributes and have, for example, a framework that provides attributes, but it will not lead to a syntax error if it's executed on PHP 7. Because on PHP 7, it will just look at this as a command and ignore it. And then it's responsibility of the framework to make sure that under PHP 7, it still works in a way. But at least you can write code with and for attributes that works both on PHP 7 and on PHP 8. And that's, I think, a benefit that allowed many frameworks to push attributes in very quickly, and they replaced other ways of configuration things in just the 2 or 3 years that have passed since it has been released. So if you went to Alexander's talk, he talked about how Symfony uses attributes excessively. And I think it's quite nice to see. I was also shown an example of Doctrine, and many other libraries also have support for attributes now. And it's really, really nice that this is usable for frameworks so quickly. So we've talked about specific use cases, but who can actually use attributes? What can attributes be put on? The targets of attributes can be classes, methods, functions, constant, class properties. This is something makes sense because you could already put a docblock on it and then use, for example, the Doctrine annotation parser from the Docblocks before. One thing that we were able to add, which was not possible before, is to add attributes on actual arguments of the function or method. How does this look like in an example? So this is a function attribute on a function. This is an argument attribute on one of the arguments of a function. And a class attribute, a constant attribute, property attribute, and a method attribute. And PHP has reflection classes for all of these. So we have reflection function, reflection argument, reflection class, constant, attribute, and method. And all of these now have the get attributes function that we saw before, where you can get an array of all the attributes. When we have called get attributes, we get instances of reflection attribute. The reason for this is, and this is one of the things I talked about before, we need to make this as PHP as possible. And PHP usually defers errors in case things are not available. And this is true for classes, functions, and everything. At runtime, when you use them, they create an error that they don't exist, but not during compilation or anything like that. And reflection attribute was sort of a way of making it possible to work with these attributes and to defer to the latest possible point an error that the attribute class that sort of backs this attribute does not actually exist. And the reason is PHP is quite dynamic. Let's say you're writing attributes and putting them in your code using some third-party library. And then at some point you decide you don't need that anymore. You build it differently now. And you remove this library, but you don't remove all the attributes. Then we want to avoid that the code crashes, since the attribute may be used on your code somewhere, but it's actually not needed at runtime, no behaviors connected to it anymore. It was a very hard requirement of some PHP core contributors that are able to vote that if an attribute is not available, it shouldn't cause a compile time crash when the class is loaded that has the attribute defined. And the sort of abstraction through this reflection attribute makes this possible. A second reason for this is maybe an extension provides an attribute. Let's say, I will see an example later, and then the extension is only used on development and not on production because it's maybe used for debugging. Then you don't want the application to crash just because the extension doesn't provide the attribute anymore to the system. The class doesn't exist. So while attribute map to classes, the only point where this leads to a crash and a sort of class does not exist on fatal error is when you call reflection attribute new instance. So up to this point, you can call get name, get arguments, you can look at what is the target of the attribute, is it repeated? All these functions can be called. Don't lead to an error, only this function, if the class doesn't exist, leads to an error that the attribute is not available. And that makes it possible to program against attributes defensively, and also allows you to use attributes without classes, actually. If you have full control over the system, you don't like that attributes are linked to classes, but you just want to work with the name of the attribute and the arguments as an array, then you can do that. You don't have to use classes. PHP has a lot of class and object-based features, but it's not only an object-oriented language. So you can use that in a non-object-oriented way as well. Also, attribute classes are not auto-loaded when a file is compiled. So while the syntax is checked, there's no auto-loading for the attribute when the compile happens. This is different to classes that are typed in arguments or that you extend from. Those are all auto-loaded. Attributes are not. So it's a bit more defensive. Another feature of attributes is that they use attributes themselves. So that's sort of a recursive way. Any attribute class that you want to provide as a system needs to have this attribute. So if you call new instance and it's a class that doesn't have this attribute, then PHP will say, this is not an attribute. Don't give you an instance of it. The benefit of this is, as I said before, PHP Storm knows about all the attributes and is able to show you suggestions which attributes to use where. Also using these flags where you can say this attribute is only allowed to be used on functions and methods, but not on classes, for example, which makes sense for our route. Not a class could be invocable, but let's say in a simple example, it makes sense to have this only for functions and methods. And by default, it's not the case, but you can specify an attribute is repeatable. In that case, you can have multiple of them on the same thing. Sometimes it doesn't make sense to have multiple because they could maybe in your language that you are adding for the attribute conflict. You would only allow, for example, if you're mapping a class to a database table, you would want to restrict this to one attribute with a table name, because otherwise you might not want to, it just produces conflicting information that you can't use at runtime anymore. So the validation of these flags are also only checked at new instance time. So when if you're using the attribute on the wrong place, only during reflection attribute new instance, you will see this and it will lead to an error. So now that we have an understanding of how the feature attributes works, the next step is, let's see some use cases. And we'll start with the PHP language itself providing attributes. And here's something that only internal attributes can do. Internal attributes can influence the behavior of the language at runtime automatically, because on the C level, when you're writing an attribute, you have hooks available to yourself that no PHP developer, application developer has. You can sort of go deep into the compiler, and when something like a function is executed, you can immediately check, does it have specific attributes, for example, and change the behavior of the language based on attributes on elements. And this is something that PHP developers now have used to implement a few nice things. One thing that is, I think in PHP 8.2 is the sensitive parameter attribute. It's nice from many different perspectives because it's also an argument attribute, which is something quite novel for people to see. So you define it on an argument. And in this case, we have like a function, a static factory function that receives a password. And I think as users of the PDO class, you know that PDO, if you produce a wrong connection string or it cannot connect, it will throw an exception. And since PHP shows also the arguments passed to functions, it might be the case that if you are not very careful, the exception will be rendered to users and they will actually see the database password in it. And this is obviously a security risk. So what this attribute does is you put it on any parameter, and when the stack trace is rendered for this, and this function is part of the stack trace, it will make sure that this variable is not shown to the user. And it's a sensitive parameter. The output on the system shows it's a sensitive parameter. You don't see what it is. On the language level, you have access to this parameter value in debugging tools, for example, to get the actual value out. But from the default way of this being rendered, the password is not shown anymore. A second attribute in core is allow dynamic properties. And this one controls deprecation behavior. It's quite nice. So PHP for a long time allowed you to dynamically at runtime add a property on an object. And it wouldn't do anything. It would just accept it, create the property, set the value. And this is a source of a lot of bugs. And because PHP does not give any feedback for it, you maybe typo the name of the property and you set a value that you want to set to some field to a typo name. And then you have a follow-up bug because you're reading the wrong value from the correct name. And this is deprecated in PHP 8, I think it was this year, 8.1 or something. For all classes, except those classes where you specify allow dynamic properties. So if you actually rely on this feature, you have to add this attribute now to avoid a deprecation being triggered. And this makes it much nicer for the 90% use case, because in the most cases, people don't want this behavior. It's a bug, and we want to be notified of this. So if we do this now without the attribute, we get creation of dynamic property is deprecated. And in PHP 9, this will actually be disallowed and changed to an exception. And except if you use this attribute, then this just works like it did before. So this is a very nice way of allowing us in the language to move forward, keep the old behavior, and allow users to opt into something, opt into a new behavior, or opt into keeping the old behavior. A third use case in core is the override attribute. It will be in 8.3. Sorry. And you can define it on any function, on any method in a class. And this just means that this function has to be defined in the base class as an abstract function. And if that is not the case anymore, it will throw an exception. So if Sebastian, for some reason, thinks that PHP unit test case should rename this to something else, then you immediately get feedback when this class gets executed with an error. Setup is not a method on the base class. This also fixes a source of bugs where you have a lot of classes extending from something. You rename the base class method, and all the code is adjusted for the base class method. But these functions here, they have behavior, but they're not called anymore at runtime. And this attribute prevents this from happening in a way that the user sees what's going wrong, instead of being just a weird bug that you have to hunt down for a few hours before you realize it. And then extensions can provide attributes. And I have an example from our profiler. We have an attribute with span, which means add a time span in the profiler for this function when you see it, when it's executed. And this allows us to extract this into the profiler and have the timing and memory stack trace information available for this function, our system, in the profiler. So this is something where behavior is also automatically done without any implementation at runtime. and extensions can provide attributes. So these are examples of attributes in core and extensions, and they have behavior that is sort of influencing how the language works. This is not possible for Userland attributes. For Userland attributes, the behavior always has to be programmed by you. So you add an attribute, program it, or the framework does it. So what are use cases to do this? For example, one use case is validation of objects. I think it's a very simple use case where you can that you can use for attributes in your own projects if you don't have a library that does this. And it's easy to implement. You define a bunch of attributes that represent different validation logics, rules. Property may not be allowed to be blank. It has to be an integer in a range of values. It has to be an email address, for example. And this way, you can sort of provide the validation logic independently from the classes and make it easy to reuse and mix and match them. And at runtime, it would maybe look a way where you would define this user object, and then you always need this mediation step. So you need this code that uses the reflection API to combine an object with attributes with the behavior that you want this attribute to mean. So in this case, our validator, it validates the object and it returns all the violations as an array of violations. For example, the name property should not be blank. How do we implement this? We implement a class assertion. We put an abstract method on it, is valid for a value, mixed value, and we return a Boolean, is valid or not. And then we implement this not blank, for example. It's an attribute again. It targets a property. And the isValid method looks, is it a string? And does it have a value, a string length larger than 0 after trimming the value? And there's also some configuration way of changing the message, the validation message. So we have this attribute, we have our user object. How do we combine them? Again, similar to the router, we validate an object. There's reflection object as an API. We pass our actual instance. In the example, it was a user object, but in this case, we are generically programming it. Any object can have validators for properties. And this is sort of the generic template of implementing this. We iterate over all the properties. We look, does it have assertion properties? And we need to use a second flag here, is instance of, because not blank extends from it. This is a special case. You don't really need to do it. You can do it differently. But this would obviously need to autoload the attributes now, because is instance of would need the actual class to be available to make this possible. So this sort of changes the things I said before about validation. Delaying it to new instance, this will make it earlier. But yeah, it's if you don't want this behavior, you can iterate over all the attributes instead just of the assertion classes one by not passing any arguments. There are different ways of implementing it. So for each property that has attributes of the assertion-based class, we validate them now. So we have an array of attributes, which are our assertions. We have the object itself, and we have the property, these 3 arguments. Sorry, they're not typed, otherwise it wouldn't fit on the slide. We iterate of the attributes, we make a new instance of it. And as you remember, the attribute has this base class assertion with the isValid method. So we know every assertion we can call isValid on it. And again here, this is reflection API. From the reflection property, we get the value of this concrete object that we pass, and then it will return the value. It will fetch sort of the value from the outside looking into this object. If it's not valid, it's a violation. we add the message and return the violations. So this is a very simple way of implementing attribute-based validator that only validates properties. Obviously, you can extend it to validate on the class level as well, on the method level, and any sort of additional things. And then you have implemented Symfony Validator. So a Symfony Validator is a component that uses this kind of pattern and is obviously much more powerful than the example I've shown. Then going back to our use case of routing, maybe you remember we used get user-defined functions and we iterated over all of them to find all the functions that have the route attribute. This is problematic because it requires all the files that have functions with route defined to be included already at that point. If they are not included, since PHP is dynamically adding more and more classes and functions at runtime, then get user-defined functions just returns an empty array, and we cannot sort of build our map of routes mapping to functions. And there's a way around it. There's a composer attribute, a composer plugin called Attribute Collector that allows us to use Composer to see all the attributes in our own code and in third-party code and make a map of them, a configuration map of them, store them. And this happens during Composer dump autoload. So it only happens once. It's stored in this file, and then the library gives us an API where we can say, give me all methods anywhere in the project that have this attribute. And this is sort of the missing point in attributes, something that we couldn't put in the language because the language is just dynamic, adding more and more things when we include more files. This makes it possible to implement, for example, a plugin system in a framework where you can use this to say at runtime, attributes, find target methods. So find me all methods that are targeted by this attribute. And then it gives me this information almost for free because it was already collected during Composer dump autoload. And at runtime, it's just one big array that can be accessed. So we can simplify our routing example by removing the get user-defined functions, use this Composer plugin, and call this method that we defined before, which collects all the routes and their functions. So this Composer plugin is something that makes it very nice and easy to provide a plugin system in your application for attributes. And I know that Symfony has implemented this sort of, they have their own mechanism. Symfony already has a way of scanning a lot of files in the system, and they just extended that to look for things that have attributes depending on their use cases. A different use case for attributes is object relational mapping. So having objects and storing their contents into a database. And this sort of goes full circle because as a contributor of Doctrine, that was the actual reason that I've worked on PHP as a language to add this, because we had the Doctrine annotation parser and we wanted to make this a first-class citizen of the PHP language. And that's possible now. So in recent versions of the Doctrine library, you can now use attributes to define how they are mapped to a database. So you have a class product, this annotation entity, it defines for the Doctrine ORM, it knows that this class is actually a class that is stored in the database. Then this attribute here defines under what table name that is, in this case, products. And then we have different kinds of way of declaring what properties sort of behave in what way on the object. For example, the ID property behaves as an identifier. So in MySQL, it's using auto increment to increase the values. And it's of type integer in the database, for example. And then we have a product name property. It's mapped as a column in the database to a string type in PHP. And then lots of different other annotations where you can declare on a class how Doctrine should store it in a database. And that makes, it's a very powerful way because it, as I said before, combines the class immediately with the configuration. So instead of having to have two files or maybe a method that is down there somewhere where I have to call configuration, it makes this really in place so that I can immediately see it. And it's also machine readable so that Doctrine, the library, can read it. And it's sort of a very powerful way of using attributes to declare and using it for declarative programming. Okay, that was it. Thank you very much for coming to my talk on attributes. You can find me via email and LinkedIn. Previously, Twitter was on it, but I left that thing. We have Mastodon now. And you find the slides of this talk on SpeakerDeck. And I will, I guess, post also the link on Mastodon again and LinkedIn so that you can find the slides for later, because it was a lot of content, and it's probably also interesting to read up on it again later. Are there any questions that you have around attributes in any way, different use cases, ideas that you have, ideas that you got from the talk that you want to ask? Okay, then one thing, I still have a bunch of these bottleneck crusher hats, and since winter is coming and you still need a hat or something, it's getting cold, you can pick it up after the talk. And then, yeah, thank you again for coming here, and yeah, have a nice conference.